Welcome to Walkabout the Galaxy, the unconventional astronomy podcast where the science is universal, the opinions are personal, and the sponsors are made up. We are strange, charming down the astroquarks, also known as First Officer Spock of the ISS Enterprise of the Terran Empire, or Josh Caldwell.
Space Barbie Addie Dove.
And Space Barbie Audrey Martin.
Coming to you from the space track at Dragoncon 2023 in Atlanta, Georgia. Remember to subscribe to us on all platforms, including Facebook, Instagram, YouTube, and Threads, but not HBO, Showtime, or Stars yet.
Oh.
On this episode, we're delighted to welcome planetary geologist R. Scott Harris, interim director of the Charleston Planetarium, and sponsored researcher at Brown University and the University of Georgia. Scott, welcome to Walkabout the Galaxy.
Thank you, and I'm glad to be here.
You can contact us anytime at wtg@ucf.edu with questions, compliments, and to find out how to get a cool Walkabout t-shirt. And in fact, you can approach us after this recording if you're interested in a cool Walkabout t-shirt, because we've got a supply here. We start off...
Mirror Universe Spock can model one after.
I can model one because it's protecting my costume. We start off the show with a stumper, which is a ridiculous question that has no meaning or importance. And today's stumper is transportational. Addie, Audrey, and Scott, you get to go for a ride on one of the following mythical creatures. Which do you choose and why? A Game of Thrones dragon. Choose your dragon. A Pegasus, one of those giant eagles from Lord of the Rings, or a hippogriff from Harry Potter. Or if you think of some other one, that's fine. What do you think, Addie?
Oh no, I have to go first.
Yes.
I have one if you don't want to go first.
Audrey, go.
I think I want a giant eagle because I could hang out on like the eagle's back and feel really safe, all nestled in the feathers, but still get the feeling of flying without having to like hang on for dear life on the back of a dragon. And the other options are really, they're just so small. Like I would be afraid of falling off. So, and if I like get hurt or something, then the eagle can just
Scoop down and
scoop me up, and then I can wake up like mid-flight, and like that's probably really fun. None of these other ones can. I guess a dragon.
You don't think the dragon would scoop you up? I think it would scoop you up.
I just can't remember that ever happening, so I'm assuming that they can't.
Yeah. Scott, what's your ride?
Well, I'm a geologist, and so it comes to mind very quickly. I'll choose another one here of something called a rock.
You're going to ride a rock.
Ride a rock.
Like a
I've heard
boulder?
rocks have
Right.
a particular affinity for falling, though.
Well, except when they're really big mythological Middle Eastern birds that look like look like. I like them because long time ago on Earth there were these giant birds called diatrema that basically looked like your worst nightmare. They would eat anything, and they were flightless birds. But the rock is the flying version of that. It also happens to be the name of the largest boulder on asteroid Bennu.
Awesome. I love it.
Very cool.
I haven't seen that movie with The Rock.
There was in Galaxy Quest, there's rock.
I want to go on a dragon. Plus, we're at Dragoncon, so it's a little bit thematic.
I think I want to go for a dragon so you can torch
that's a good
stuff,
answer.
too, while you're flying around.
Or ice stuff, depending on the iteration.
Today we'll talk about many of the surprising and fascinating places that water is hanging out in the solar system and why we care. But first, this episode of Walkabout the Galaxy is brought to you by Orbital Mechanics. If you're having trouble with nodal regression, apsidal precession, or even chaos, bring your orbit to Orbital Mechanics. Providing a full range of services, including adjustment of eccentricity and inclination, Orbital Mechanics will provide you with a quick and transparent estimate on getting your orbit back into shape. Orbital Mechanics also can make sure your true anomaly is truly true. Mention Walkabout the Galaxy, and for a limited time, Orbital Mechanics will change your semi-major axis at no additional charge. If you're missing any of your 6 orbital elements, Orbital Mechanics has full sets available from ellipses to hyperbolas, or order a la carte. Orbital Mechanics, get in the zone.
AutoZone.
And artwork for this episode's sponsor, provided by Ilea Caldwell. That name rings a bell. You can follow her on @ReasonsMyFriendsHateMe on Instagram and Patreon. And I should mention also, believe it or not, we're the astronomy podcast with music videos. Our first music video is on YouTube, sung by the incomparable Lainey Pejos, who joins us in the audience today. And also, believe it or not, this is maybe more believable, our second music video is still in production, and that's what I said a year ago at Dragoncon 2022, which is very embarrassing. We have a wonderful recording, but the video part has been a little bit more challenging. Anyway, so today we're talking about water in the solar system, and the picture here is
Do we want to do any space news?
Do we have space news?
We have space news.
Go for it.
So one of the, for those in the audience, we do the little pieces at the beginning to tie into things that are currently ongoing. Sometimes we do nerd news, which is TV shows and things like that, but those
we have
aren't
nerd
really...
news trivia.
Ah, perfect. Okay.
Oh,
But the space news, let's see. So I think since we last recorded, there has been another human launched the ISS.
Nice.
New Crew 7.
It actually woke me up, that launch.
Oh, no.
Because it was like 3 in the morning.
And you heard it?
I first thought it was nuclear war. And then I was like,
Makes
wait a
sense.
minute. I think there's a
God.
launch tonight.
One of the great
which
things
was a
about
relief.
living in Orlando is that you sometimes get to hear the launches, especially late at night.
Right. When it's
Pretty
quiet.
fun. When it's
Yeah.
quiet. There was...
the telescopes.
Yeah, we
Gemini
were just-
North and Gemini South were
hacked.
they were hacked because they got a lot of really useful
What?
hackable
Yeah.
information. I don't know. Yeah.
There was just a story about so there's these two big telescopes, Gemini North and Gemini South. One is in Hawaii, one is in Chile, and they were hacked. The NSF has reported that the telescopes are down for now because they got some sort of cybersecurity attack. Why?
Well, I just
What
got
did
back
they-
from Chile. I promise it wasn't me.
Was it you?
It was not me.
Did you facilitate it?
It was, and
Uh-oh.
I won't say whether or not I saw anyone suspicious.
Guilty.
Okay. Wow.
Yeah.
Yeah.
This was just
Kinda random.
hacking for the sake of like screwing up the telescopes.
Maybe it's just practice
Yeah. Okay.
to hack other telescopes. I
Yeah.
don't know.
Cool. When we think about water in the solar system, there's a lot of discussion about like where did the water on the Earth come from. Here we've got a picture of Comet 67P. This is taken by Rosetta. Thank you. And this is a very icy object, and so what we're seeing here is evaporation of sublimation of ice from the surface of that. So recently there's been a lot of discussion about like whether ice on the Earth and the Moon came from impacts after the Earth formed, from comets coming in and hitting it, or whether the water on the Earth sort of formed together with the Earth. We had on a recent episode talked about some study where, I think with JWST, is that right? They saw evidence of water in the protoplanetary disk.
Yes. Yes.
So it's further in than the so-called ice line where water could condense.
Yeah, so JWST has this really phenomenal capability to see sort of different parts of a disk of a forming planetary system and a protoplanetary disk, and can actually see in and could detect that there is signatures of water sort of further in than they expected from just like typically modeling because of temperatures being very high close to the star in the center of a forming solar system. You don't expect to have water there, but JWST was able to see, well, signatures that seems like water was very hot and very close to the
water
star.
in a high temperature region of an extrasolar planetary system, which really changes the whole paradigm for how terrestrial planets like the Earth and Mars get their water, because a lot of research recently has really been focusing on this impact thing. And Audrey is a asteroid spectroscopist,
Yep.
and Scott also as a planetary geologist knows a lot about water in the solar system. So we've been for a long time thinking about water impacting, coming in after you form the planet, and then you have a bunch of impacts of comets coming in from the cooler regions of the solar system. But we care so much about water, obviously, because it's necessary for life.
Yeah.
It's also good rocket fuel.
It is. It's good for in situ resource utilization purposes, but like for most part, when we're looking at things in the solar system, we're always curious, where is the water? How did it get there? Where was it formed initially? And can we use it?
In what form was
How
it
can we
in?
use it?
Like, is it icy? Is it
Yeah.
liquid? Is it stably liquid, or is it like transiently liquid?
Is it
meaning
locked
like
up in
can it
rocks?
stay liquid on the surface for a long period of time, or is it like, oh, here's some liquid water, oh no, it's gone like immediately? Like a lot of those things are very interesting and very important.
Yeah, a lot of times when you hear about water, you don't know whether you're talking about molecular water or the stuff we call hydroxyl OH. And then even with both of those, sometimes you don't know if it's actually combined with silicon, which is basically, makes up the silicate rocks. So if it's all bound up like that, then the utilization thing's a problem.
Right. Yeah. And this is, I'm glad you mentioned that, because there's lots of headlines like water discovered on the moon, and what that may refer to is not actually even H2O molecules, but OH. So it's those building blocks, and it's not a pool or an ice cube of water necessarily.
But hydroxyl, so if we're talking about having water there in terms of if it's useful for life and things like that, it needs to be water generally. But if it's hydroxyl, if it's O and H, and it is part of those molecules, those are useful for utilizing and separating and making hydrogen and oxygen and rocket fuel. So
yeah.
So we for a long time we've been sending missions to Mars to look for water, right? That's been sort of the goal of a bunch of the Mars missions, is to look for water, look for life. We've found water on Mars. I don't know how many times now.
I know, we have lost count.
There's a lot of headlines. Water found on Mars, and it's like, well, yes, because we already found it there. But it's exciting, right? We find it in different places, sometimes in places we don't expect. We know that there's a lot of water at the polar regions of Mars because they're cold and they have these ice caps. But we've also we've talked about this before, but we've started to see more signatures of water near the South Pole. There was just a mission called Chandrayaan-3 that landed.
Moon now, not Mars.
Oh, sorry. Did I say moon?
You said Mars. I'm just making sure we're doing
moon.
Yeah.
I switched to the moon. So we're starting to look for water on the moon, and we've detected signatures, a lot of OH signatures in the polar regions of the moon. We've also detected water signatures from neutron signatures. So if you're using neutron spectroscopy, you can tell that the materials are different and it's probably water. But again, it could just be hydrogen. It could be OH. There's a lot of ambiguity in those detections.
Well, we did have this mission a while back that kind of almost gets ignored these days, called L-Cross, that actually did this novel thing about just crashing into the moon, knocking whatever's there in the shadows out. And not only did it see, OH, you saw water, you saw more importantly, all kinds of things that we call volatile, the things that you heat up ought to just go away, are all trapped there somehow. How they're trapped, hopefully we'll find out one day.
Yeah, that's one. A lot of times when we're talking about how things form in the solar system or how things get the shapes they get, we always say, it's probably an impact, because that's a really good way to explain things in the solar system. But it turns out it's also a good way to learn things about the solar system. Just slam something into something else, right?
Those are my favorite missions.
We like to make things go boom.
Yeah. Mm-hmm. So think about the large, what is it, Hadron or Hadron?
Hadron.
Collider, which is just smash. That's high energy physics, is smash particles together and look at the pieces. Yep. And sort of, you always think okay, is that a good way to figure out how a car is built? It's smash two cars together and pick up the pieces. Maybe not so much, but for particle physics, it probably does work okay. And for planetary science, like you were saying, Scott, it actually was really helpful.
I'm an impact petrologist, so basically, if I walk into a room, my message is I'm blowing something up.
Okay.
Nice.
Let me smash something into it or blow it up, right? Yeah.
We have a pretty good history of learning things about things by running things into them.
And there's a great tradition in planetary science of explaining oddities in the solar system, like must have been a collision. The origin of the moon itself is due to a giant impact.
Yeah. And we so Chandrayaan-3 recently landed near the south polar region of the moon. It's actually not in the south polar region. There's been a lot of good PR about this mission that says it's in the south polar region, but it's up sort of at 69 degrees south, which is actually sort of outside of this. So there's on the screen right here, if you're in the room, you can see sort of a map of blue. Most of that stuff is within 80 degrees south longitude. So 90 is the pole and 80 degrees. So it's in this really narrow region. They're sort of up 70-ish. So they're a little bit outside of where we mostly see these water signatures, but it's still further south than any other NASA missions have landed. But so they recently landed. Russia was trying to land the Luna 25 mission, and it crashed. Actually, I don't know where, but LRO recently saw it. So,
Oh, really?
I saw the crash
Yeah,
site,
yeah.
Good.
So LRO is the NASA orbiter that's orbiting the moon, and they're able to see changes in the moon because they're imaging it all the time. And so when something crashes into the moon, sometimes it's natural things like meteorites, but also spacecraft. Turns out there's a new crater right there. We think we know what that is. So yeah.
So in the image here for the South Polar region, which is where the Artemis 3 landing will take place with humans, because of the orientation of the moon's spin axis and its orbit, near the South Pole, there are regions where in the floors of craters where the sun never rises, and it hasn't for a very, very long time. So it's very cold. So if you can deposit some water molecules there, they're going to stay there. And so if a comet hits the moon and it's depositing a whole bunch of water molecules, it's hot. They sort of do what's that game when you're a kid? Lava
Floor is
or
lava?
Something? Yeah.
Josh doesn't know games from
I
childhood.
don't know childhood
This is
games.
the thing we've learned
She
about
doesn't
it.
know
Yes.
Duck
The floor
Goose.
is lava. Duck, duck, goose.
That's still made up. I don't believe it.
100% a real thing.
those water molecules hop around on the hot plate of the moon until they land on a cool place, which happens to be the only cool place where you're going to stick around for a while is the South Polar region. And so the other cool thing, or neat thing, about the South Polar region is that on the rims of those craters, the sun never sets. So you can put your solar panels vertically. The sun just sort of skirts around on the horizon since there's no atmosphere. You have a nice continuous source of power. You don't have to deal with that pesky lunar night. And just before we move on to our next object, I want to let Space Barbie Addie give a shout out to her mission to the moon coming up.
It's not going anywhere near the South Pole.
No, it's not.
But it's still a mission and it's still going to the moon and it's still really cool.
And
Thank
we're going to
you,
look for
Space
signatures of
Barbie
water.
Audrey.
You're welcome.
Yeah, so
Spock.
at UCF, we're leading a mission called LunarVise, Lunar Vulcan Imaging Spectroscopy Explorer.
It would have been really embarrassing if you didn't remember what your own acronym mission
There's so
stood
many
for.
acronyms in my head. Sometimes they get confused. So this is a mission that's going to the Gruithuisen Domes, which is it's sort of equatorial, a little bit north region on the moon. And there are these really interesting volcanic domes that have formed on the moon, and they look like domes we have here on Earth. But the trick of that, right, is that like these kinds of features on the Earth usually form in the presence of water and often in the presence of tectonic plates. But like those aren't things that are on the moon, right? So there's a big sort of geological questions of how these things formed and evolved. And so we're sending a mission there with a bunch of instruments, some thermal instruments, some cameras, a gamma ray neutron spectrometer to try to understand the minerals that are there and the history of these interesting volcanic regions.
So we'll talk about that at Dragoncon 2027. Okay. Cool. Moving further out, so earlier we were talking about like where does this water in the inner solar system come from? It may have formed, gotten locked up in molecules like Scott was describing as those terrestrial planets formed. Some of it certainly delivered with comets.
Well, one of the cool things that we worry about that a lot of people don't think about with our rocky planets that we've done research on over the last 15 years or so, used to be thought that a comet or an asteroid, even a comet with all that water in it, you run into something at the kinds of speeds and the energies involved, everything just goes poof. It is literally, I've seen quotes of that in articles that say it goes poof. And it turns out doing actually impact experiments and looking at the evidence of materials formed by impacts here on Earth into things where we know there was water present, we can trap an enormous amount of water in melts from those events. And if that melt goes into the, down deep in the mantle of the planet or sitting around in the regolith of the moon,
You got it.
It's going to, it's actually a reservoir that's going to kind of leak out over time or outgas over time. So that's something a lot of people aren't that aware of. And I think we're going to find out there's a lot of that stuff out there.
So is that, for the moon, which formed from a sort of planetoid impact on the Earth, which then also created this sort of vapor cloud in orbit around the Earth, is it also possible that a lot of the primordial water from the Earth prior to that impact was incorporated into the subsurface of the moon?
My guess is probably yes.
Yeah.
The question is, and hope people like Addie are going to find out how much and how that has been changed over time as it has evolved in magma systems.
Cool.
Yeah, there's a lot of simulations we do to try to understand how the moon formed and the history of the materials that make up the moon. So like there was this giant impact, everything was sort of vaporized, but a lot of newer models that are higher resolution and can include more sophisticated physics because of computational advances, right, are able to capture a lot of those volatiles more even in the models now too.
My second favorite moon in the solar system after Moon is Enceladus, and
I would have thought like Pan or Atlas would be your favorite.
well, I do, yeah, okay.
You got a soft spot
Fair
for
enough,
those
but we'll
little,
come back
little
to
friends.
those on another episode. But and Enceladus is amazing because it's not very big. It's
It's so tiny.
It's a little baby.
few
It's
hundred
just a little tiny
kilometers.
moon.
It's just barely big enough to be a sphere, and it's icy, as most of Saturn's moons are, and it has geysers. Somewhat coincidentally, from the South Pole. We're just talking about South Polar
Everything's happening
water
at
on the moon. There's a system of geysers at the South Pole of Enceladus, and the modeling indicates that is, we've flown through those geysers with the Cassini spacecraft and measured the composition, and the composition is primarily water and water products like OH, and the source of that water is a subsurface liquid water ocean. So it's not just like a comet with ice evaporating. There's a subsurface ocean that's actually potentially quite close to the surface of Enceladus. There was a recent paper indicating the analysis of Cassini data where they discovered phosphorus.
There's a
in
recent
these
Cassini
plumes.
paper.
I'm still writing Cassini papers.
I know.
Annie.
I love it.
Give me time. Give me time. And so it's a potential habitat for life, and NASA talks about exploring water worlds, and this is one of those water worlds that they're talking about. They're mostly moons in the outer solar system.
You have infinite time for Cassini. I mean, people are still using Magellan data, so.
Okay.
That's true.
Thanks.
And Voyager, like
Yeah,
I
well,
knew
Voyager's
someone
still going though.
Well, that's true, but like old Voyager data.
Uh-huh.
That's true. Yeah. There's been some cool new papers recently from a lot of these really old spacecraft missions.
So at Saturn, the temperature that you would expect, like if you just take a rock and stick it out in orbit around Saturn, it's going to be at about 90 or 100 Kelvin. So that's about minus 170 Celsius. That's very
What
cold.
is that in Fahrenheit?
Minus something.
Yeah.
Well below zero,
Several.
as we like to say. Several below zero. So water is, hard as a rock and very
Huh.
inert at those temperatures.
Literally.
So the question is like, where does the energy come from to keep a liquid water ocean under the surface of Enceladus?
Is it aliens?
That would
Is
be
it
Never aliens.
Is it a
That
whole
would-
bunch of giant
that would be
impacts?
awesome. That would be awesome. What did you say, Audrey?
Is it a whole bunch of giant impacts?
Oh, I like it.
Well,
Probably not.
when the
Probably
when,
not. But what if
well,
it is?
kind of.
Well,
Kind of is because it's heat from original impacts.
I
that
guess
formed
that's
it.
true.
Well-
I was trying to be facetious, but yeah.
You
if
failed once
I
again.
failed.
in your attempt.
I'm leaving. Sorry, everyone.
It's hard to be facetious if you're asking, is it impacts? Because it is almost always impacts.
Damn it.
Scott, yeah.
And there actually there is a published model for Enceladus of a not original impact, but one that came later, actually generating the amount of heat required for this. But then there's also been a lot of as I call them, astromechanics, or astromachinists maybe, that
Orbital mechanics. Should we get them on the phone?
yeah, they've toyed around with exactly how Enceladus does or doesn't get along with its big neighbor there, Saturn, and it's sort of evolved over time exactly how much tidal forces actually can affect it.
Yeah, it's not as clear-cut a case as the next icy moon that we'll look at here. It's just another picture of the South Polar region of Enceladus from Cassini. I just, find this image stunning. It's just amazing to see this kind of activity on a little tiny moon. If it has been going at this rate for the age of the solar system, about 1/10 of the original moon would have evaporated. Of course, it may be a more recent phenomena, as you were just mentioning, Scott. But it turns out also that it's easier to keep liquid water liquid than it is to melt ice. And so, you could have a big event like that a recent impact could do it, or you could have those original impacts and original radioactive material creating that liquid ocean, and then those funky orbital mechanics folks tweaking things to cause enough flexing of the moon, enough friction in its interaction with the other moons orbiting Saturn to provide enough sort of frictional heating, tidal heating, to keep that subsurface ocean liquid for potentially for the age of the solar system.
One of the more popular icy moons that probably has a subsurface ocean is Europa. And I think there's another talk about Clipper during the track sometime this weekend. Tomorrow? Maybe.
Maybe it already happened?
Yeah, Monday 10 o'clock.
Monday 10 o'clock if you're here at the con. And so, because there's a upcoming mission called Europa Clipper that, you guessed it, is going to Europa. It's going to clip it. No, it's gonna orbit it. Hopefully it doesn't clip
Hopefully it doesn't
Oh,
clip
God.
Well,
I'm so
it's going to
stressed.
orbit Jupiter in
That's
very
true.
eccentric orbits. So that's where the Clipper comes from. It's going to clip by
Yeah.
Oh, that
over
makes
time.
sense. Okay.
Yeah.
Yeah.
Because otherwise you just roast in the radiation.
Yeah. So it's this really
Europa
interesting mission
roaster.
that we hope it's not that either, right? There's like Mars Polar Crasher, Europa Roaster. Hopefully it's none of those. So Clipper is going to be going to Jupiter, as you mentioned, right? And orbiting Jupiter. You mentioned the radiation belts of Jupiter. So Jupiter has these really, really intense radiation belts. So when we send spacecraft there, it's actually really hard for them and the electronics and all the instruments on the spacecraft to survive. So with the Juno mission, which has been ongoing, it has a really eccentric orbit, so it comes close sometimes and is far away outside of the radiation belts more often. And so I think Clipper, right, will have sort of a similar orbit where it's close in sometimes and it comes close, and its close approaches are near the orbit of Europa, and then it goes further out and sort of cools off for a little bit, resets its circuits.
Dips its toe in the water, so
Yeah.
to speak.
Comes in and out.
So I love the graphic on the upper left, and I don't know if Scott, if you have any comments on this, but it shows the total water content of the Earth represented by a giant droplet, and the total water content of Europa, which is a bigger droplet. So more water on Europa. So if you think about ocean worlds in the solar system or water worlds, there's more in the outer solar system than there is here on Earth, which we think of as a pretty watery place, fortunately.
Well, I have a lot of friends that have worked on getting to Europa for a very long time, and they wish they could just go dive in, right?
Yeah.
Go fishing.
Right.
Particularly the Bob Papalardo, the principal investigator, is from up in the northern part of the U.S., and I'm sure would love sitting there ice fishing.
fishing.
Ice fishing.
He will need a long line. It is at least tens and maybe well over 100 kilometers, I believe, down to the liquid ocean of Europa, but potentially another habitable environment. Europa Report, for a little nerd news shout out, is a fun science fiction movie about life under there. You need water, you need raw materials for life, and you need some source of energy to drive things. So with Europa, Scott, you were talking about what would keep Enceladus warm enough to have a liquid ocean under the surface. With Europa, it's quite clear the tidal heating between Europa and Io and Ganymede. They're in orbital resonances that produces a lot of frictional flexing that produces enough energy to keep that interior molten. Alrighty. On Walkabout the Galaxy, we have a trivia. Our trivia is nerd-themed in this episode.
Isn't it always?
Yes. We love to nerd out on science fiction movies and TV shows, so it seemed appropriate at Dragoncon to have a nerd-themed trivia. The pictures here are from the movie Metropolis. And by the way, thank you, Addie. This trivia is actually contributed by our listener, one of our listener, because we have one.
Thanks for expanding our
Hopefully,
audience, everyone.
if any of you would like to be our second listener, you can sign up with me after the show.
Larry Novak.
Larry Novak, thank you for sending in this trivia
Thanks,
question.
Larry.
And for those in the audience, please don't shout out the answer. We'll get our question
Yes.
now, and we'll poll you all when we're answering it later. I'll phone a friend in the audience.
Metropolis, one of the first maybe the first feature film science fiction movie from 1927. Actually, U.S. copyright, I just learned this preparing for this episode, expired on this movie January 1st of this year.
Let's
so
do
it's in
it.
public domain. There's a whole bunch of different edited versions. The original cut was quite long, even by today's standards, like I think close to 3 hours. Then there were some shorter edits. Anyway, there's different versions out there you can see. Our trivia is, oh no, our trivia is not displaying. Why is our trivia not displaying? I'm going to have to read it. Which of the following TV shows and movies did not have a quirky robot companion? Because we also love quirky robots. The Hitchhiker's Guide to the Galaxy, Quark. Anybody here remember that show, Quark, with Richard Benjamin? The Forbidden Planet, The Adventures of Buckaroo Banzai Across the Eighth Dimension, or
What?
The Day the Earth Stood Still.
Buckaroo Banzai?
Buckaroo Banzai.
Buckaroo.
Buckaroo Banzai with John Lithgow.
Oh, I love John Lithgow.
Yeah. So all of those had a quirky robot companion, save one. Which one did not? And then there will be bonus trivia if you can remember the names of any of those quirky robot companions. Okay.
Cool.
We'll come back to that after we move out to even more water worlds.
More
Audrey.
water.
Yeah, a lot of the so we just talked about Europa and Enceladus and tidal forces that are keeping these satellites warm. That is not the case for the Uranian satellites. There are no tidal forces that would keep them warm enough for any kind of liquid ocean.
They're
However,
like pretty small and pretty far out.
pretty small, super duper far out. But there's a new study that we've talked about on the pod before, but I'll share with all of you people here, that hypothesizes a similar type of liquid ocean on the Uranian satellites, which is bonkers.
That's
It's
crazy.
super bonkers. It doesn't make any sense. And the idea is that there's a whole bunch of salt that was originally mixed in with the materials that were coming together to form these satellites, and the salt acts as an antifreeze, which lowers the
Melting point.
melting point. Thank y'all. Which lowers the melting point, so it can stay liquid at colder temperatures, which is really cool. And it was kind of originally thought of because there were like weird ammonium spectral signatures on the surfaces of these satellites, and they were like, what? Like that can't. Oh, they can't. Oh goodness.
Oh, we have a riot outside. It's okay. I've got
They hate Uranian satellites.
here, throw my agonizer at somebody.
Oh, good. I don't remember what I was saying, but they're really cool. And so
And we see salty we see salty water other places in the solar system,
Yeah.
right? So this
Oh,
is
I remember
another
what
common
saying.
thing that we can use to sort of explain, like on Mars, why you might have water in places where you should be too cold, but if there's
Right.
salts mixed in, it lowers the melting point.
right, and so this ammonium isn't it's not super stable on the surface for a really long time. So to find it in these spectral signatures, it would have had to have been recently deposited. I don't remember how recently, but it would have to be kind of
Geologically
recent.
recently.
So way back in when the Voyager 2 flyby occurred, and right after that, back in those good old days of the space exploration, as soon as a mission like that happened, a book was written, and there's this volume for Uranus that's like that thick, and there are papers in there that talk about ammonium compounds,
really?
and really weird exothermic reactions that occur between those and water ice. And is that something that's talked about now in terms of the models for how you can get some of this potential relatively recent activity in the subsurface?
Not that I'm aware. Would that be would that create water on the surface, or would it be in the subsurface?
To create in the subsurface and maybe down deep in the long grains and sort of create a system.
Uh-huh.
Oh, yeah, maybe.
Then maybe
I
there's
remember
some
that book.
recycling.
I don't.
I still
probably
have
on
that
your
book.
shelf.
Dating
Somewhere.
myself. Yeah.
Yeah, me too.
But yeah, these moons, as Addie mentioned, we see antifreeze in the form of salts at Enceladus also for that liquid water ocean there.
And I just want to mention that this image that you all in the room are having the great benefit of being able to see, our radio listeners, generally can't actually see these images. But this is a JWST image that's just like so amazing. I don't know. I was
so
just
cool.
ogling it for a minute here.
It is. I'm old enough to remember when the rings around Uranus were discovered, and they were discovered by stellar occultation. We did not have the capability to image them at that time. And now it's like, yeah, there's just a picture, and there you see them. It's like, that blows me away because it was like this squiggly line discovery in 1977-ish
And
or
on the
so.
monitors, you can see all these like galaxies in the background and other things. This imagery is phenomenal.
Yeah.
And most of these new results are actually coming from JW data.
Yeah, that is also true. Some of the spectral results came from IRTF,
Which is a telescope
which is a telescope on Mauna Kea in Hawaii.
that apparently didn't get hacked.
Which hasn't yet.
Yet. Who knows? Maybe it's next.
Yeah.
That IR data.
Yeah, and so there's right now there's a push. I don't know the right word, but like there's some
Movement?
excitement. There's some movement on a Uranus flagship mission, a NASA mission to the Uranian system, and which would be really, really great because we haven't sent like an orbiter to Uranus, and
It's really far away.
it's like super far away, but
really
also
hard
like
to do this mission.
okay,
It'd be so fun.
that's why it's taken so long.
Yeah.
But like now is the time.
Yeah.
Now is the time.
So
and
this is it called the Uranus probe and orbiter or something? Is the I
don't
assume
know
at
if it
some
has
point
a
they'll give it a
name
It
name.
doesn't have a name yet,
Yeah.
but there's a lot of discussion about it. I mean, you could name it. I think the leading candidates are Herschel and Shakespeare.
yeah.
Oh, yeah.
So a lot
Yeah.
of the moons of
As you can see
Uranus,
here.
not all, but a lot of them are named after Shakespearean characters.
Is that why they're so salty?
Yep, that's it. Yeah.
Yeah, Herschel would be, of course, discovered Uranus with his telescope outside of London. And didn't he initially name it after
George.
Yeah, Planet George.
George.
That would be really
After
fun
the
too.
king.
Oh, the mission should be called George.
Oh, that'd be
I'm
good.
sure there's an acronym
We could
that
make
could be
it an
made from
acronym.
George.
Oh, please, no acronyms.
Geologic exploration of rings, geology,
and everything.
everything at Uranus.
Yeah. And then Uranus is like
at Uranus.
lowercase.
Well, speaking of
so, yeah.
terrible acronyms, there's
Hey, that was pretty good.
we discussed the Europa Clipper mission. There's another mission en route to Jupiter as well to study the water worlds of Jupiter, which is JUICE. And that's a terrible acronym because JUICE stands for Jupiter Icy Moon Explorer. Did I get that right?
That's correct.
Yeah.
Yeah. So there's no M in JUICE.
It's not a real
You might have
acronym.
noticed, but there is an Icy Moon
You didn't know
Explorer.
icy moon is one word?
Right. Yeah. So here are those
Old icy moon.
5 largest moons of Uranus. They're relatively small as far as big moons go. So yeah, very interesting and surprising. And here's kind of a hypothesis of where those salty oceans might exist on the 4 larger ones of those moons.
The smaller one, Miranda, is not. They don't expect Miranda to have any liquid.
Miranda's so crazy.
Miranda's super crazy.
Yeah,
It's
and
a crazy spectra.
the images here, of course, are from Voyager 2. So
Yeah, of course.
while we do have amazing JWST images that show the rings where we did not have ground-based images before, our best images of the rings as well as the moon still come from Voyager 2. Okay, are you folks ready to go for your trivia?
Okay.
All right.
Is our
Which of
audience
the-
ready?
Which of the following TV shows and movies did not have a quirky robot companion? Was it The Hitchhiker's Guide to the Galaxy, Quark, The Forbidden Planet, The Adventures of Buckaroo Banzai Across the Eighth Dimension, or The Day the Earth Stood Still? I'm looking at Charm Space Barbie Addie Dove.
What?
I mean, I've obviously
happened
never
to my
seen
trivia.
Quark. Well, you had a version that didn't have the trivia, so you probably opened the
that's
wrong
probably,
one. Rain's making a lot of gestures over there. She's telling me the answer, and it is Buckaroo Banzai. I don't know if that's right, but I'm going to guess.
That's really surprising because I would think Buckaroo Banzai is the robot. But maybe that's a trick. Maybe you're trying to trick us.
Yeah. What do you think, Audrey? Have you seen any of these?
I know it's not the day the Earth stood still. I don't know if I would call it a quirky robot sidekick.
Have you seen any of these?
I've seen
Audrey?
Hitchhiker's Guide.
Uh-huh. And do you remember if it had a robot?
No. I guess because of how I hesitated, the answer is no to that.
That was a good tell. Yeah. Scott, how about you?
Shares a name with a famous Martian. Marvin.
Matt Damon.
Yeah, that's right. Scott.
Is he a robot?
Is he a robot?
Yeah.
I've never met him. I don't know.
Marvin the Martian.
Might be.
You're right. Marvin the Martian is the Hitchhiker's Guide quirky sidekick. Scott, I have a feeling you know the answer.
I know 3 that aren't the answer, but the other 2 I honestly don't know.
Which are the 2 you don't know?
The Buckaroo Banzai and the Day the Earth Stood Still. My brain's racking about that one.
So the iconic Gort. It's not really a robot sidekick.
He's not a sidekick.
He's not a robot sidekick.
He's pretty quirky.
And the Robbie.
Yeah. Robbie from the Forbidden Planet, and from Quark, it was Adam or something like that, I think was the name of it.
So it is Buckaroo Banzai.
It is the Adventures of Buckaroo Banzai across the
I knew it. I knew it the whole time.
That's Rain's favorite movie.
Space Trek.
It's mine too.
Yeah.
Yeah,
we're gonna go watch that right after this.
For a second time.
Yeah. It's just been a long time.
Yeah.
Scott, what do we have to look forward to in terms of water in the solar system? What interesting aspects of water in the solar system have we not touched upon?
Well, the one that's out of preeminent interest right now that we have a mission called Da Vinci that is going to investigate is water in the strangest place you'd expect water, where on a planet that has a surface that's the hottest it can be, and that's Venus, but not on the surface, but looking at the clouds. And could something be living in those clouds because of that water being in there?
That would be the strangest place. So you're right. I mean, that's 900 degrees Fahrenheit at the surface of Venus.
But it's quite temperate up in the clouds.
Yeah, it's a habitable. It's the Goldilocks conditions there.
Yeah.
Is Da Vinci the mission that's going to drop through the atmosphere? Yeah. That's really cool.
Da Vinci, and then it has a geological companion called Veritas that has suffered some funding setbacks.
Yeah.
So Da Vinci is an orbiter and a probe.
Da Vinci is a dropped probe and orbiter.
Yeah.
And then
so an atmospheric probe.
Atmospheric
it's not
probe.
Do anything on the surface.
Yeah.
It's really to study the atmosphere.
Yeah.
A temporary lander.
Temporary lander.
What's the timeline for Da Vinci?
I'm not sure right now. In this decade, in this decade is the best way to characterize it right now. And then Veritas has been pushed back theoretically to mid next decade, if it flies at all.
Okay.
Oh, that far. Last I heard was at least 3 years, but there wasn't anything beyond.
At least 3 means.
Well, yeah, I know what that means, but I didn't know that there was anything definitive beyond that. But now it's at least 10 years.
The last update I heard was it would fly with the ESA mission that would have been the follow-up to both of them. Yeah. So it's sort of weird that you're flying, and they're really upset about that because you'd be flying something that's designed to set the stage for something else.
Right.
Flying at the same time. That doesn't make any sense.
Let's just send Veritas.
This happens though. Some things that don't make sense, fall to the budget problems. One of the things that one of our favorite, or my favorite, fun facts about Venus, actually, you were just mentioning, looking for water in the upper atmosphere or temperate zone. There's an altitude, I can't remember exactly where in Venus's atmosphere. Sorry? 50 kilometers or so.
Sure.
Somewhere up there high in the atmosphere where the atmospheric pressure is about what it is in this room. And the temperature is actually not too far from what it is in this room. The composition is different than what it is in this room. So there's that. But you wouldn't necessarily need a pressure suit. You could live there with a supply of oxygen, and you wouldn't necessarily need any heating or cooling. And maybe there'd be water somewhere around there in those Venusian
And
clouds.
the crewed missions of the next generation of dirigible pilots.
Right.
That would be a fun aspect to something that doesn't deal with impacts. I'd fly on that.
Right.
Dirigibles on Earth.
Cloud City mission to Venus.
Lando.
On
Yeah.
Titan.
And then Titan,
Titan.
of course, is another one of our favorite imagined destinations because Titan is the largest moon of Saturn. We didn't mention it as a water world, but it is also a water world. It has a subsurface liquid water ocean, quite deep. Titan is quite large. It's bigger than the planet Mercury, but its composition is much icier than Mercury, so its gravity is weak. So one of the things we love about Titan is you've got a relatively thick atmosphere. The pressure on the surface of Titan is about 1.5 times what it is in this room. But to get that pressure on a world with a low gravity means you need to have a very thick, it's a lot of atmosphere, so it's very thick and soupy. And with that low gravity,
Just
that
like
means you
Orlando.
could strap some nice cardboard or some kind of wings on your arms and flap vigorously, and you could fly around.
Maybe that'll be my costume
Wait, really?
for con next year.
Yes, you
I
could,
had no idea.
yes.
Oh yeah, we've talked about this a bunch before you joined the podcast.
Oh
I
my
think.
God. And
Yeah.
then you were like, you know what we're not going to talk about? What
Yeah,
Audrey
so-
would love. That
we
sounds
were saving
amazing.
it- we were saving it for this opportunity.
Wow.
So that whole
Okay,
thing
thank
about
you.
having that experience of flight with the giant eagles,
Yeah.
Audrey, you can
Yeah.
just go to
Do it on
Titan.
Titan.
I could
You
be
need
my
to
own
be-
eagle.
You need to be very well protected against the cold,
I'll figure it out.
and you need a
parka.
supply of oxygen.
Okay.
Well, while it may have felt like trying to get from the Hilton to the Marriott at Dragoncon on Saturday night, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the cosmos.
Be sure to follow us on Facebook and Instagram to get all our updates and check out our website at walkaboutthegalaxy.com.
Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
You can ask us questions via the ancient technology of email at wtg@ucf.edu.
Our theme music was composed by Richard Rusik. Production assistance is provided by Logan Basinger, Lorraine Glynn, and the Space Track team here at DragonCon. Thank you to Scott Harris for joining us today, and thanks to our listeners right here at DragonCon. Stay safe. I'm Josh Caldwell.
I'm Space Barbie Addie Dove.
I'm Space Barbie Audrey Martin.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
Hi, Barbie.
Hi, Barbie.
Hi, Barbie.